Hi class, this is your professor Amy Hohers, and I'm going to try to do these recordings for each section in our class, each lesson, so that you have something to go by besides just reading the material. And I first wanted to show you where you can get your materials to print so that you can follow along as I do the videos if you want. This is strictly for yourself. I would recommend doing it, but of course I'm not going to be having you turn it in and checking it or anything like that. But if you want to be successful, I think this is a good first step, is to follow along with these videos and fill in your student notebook as you go. These are the things that if we were in a face-to-face class we would be doing together in class. So the first thing that you would need to know is how to get to the materials. And so once you're logged into MyMathLab, if you click on Student Materials to print, you will see over here where it says Student Notebook, and you click on In-Class Student Notebook, and it will pull up this this digital copy of what you would buy in the bookstore if you went and bought our book in the bookstore, which then would come with a code. But if you'd prefer, you could buy your code online. Of course, you can use your first few weeks free. I would recommend doing that just in case anything goes wrong, just to use your first few weeks free. But if you don't want to do that, or you've already purchased the packet, you can use that. You can buy that in the bookstore. But here online, if you go to that, it will pull up this digital version. And I'm just going to close this because I've already got it on the correct page here. And if you scroll down, you'll find where the lessons start. They actually don't start until like page 27, but this is what I'm going to be following along with during the lectures that I'm going to do for each of the units. So if you want to pull this up, print it out. The only bad thing is they don't really leave room here for you to put your answers necessarily, so you might want to have these printed out and then write out on a piece of paper, or maybe you just want to write it out on a piece of paper. This is completely up to you, but I wanted to show you where the resource was at. So now starting with lesson 1A, we're going to again work through the questions that are asked. This is what we would do in class if we were meeting face-to-face. And I'm going to warn you right now that the technology that I'm using for this, the tablet, I've never used before, and so might be a little bit of a learning curve as I go here, but hopefully I can get the point across. So the first question that they ask here is, jot down anything that you know about the number 1 billion. So if you were discussing this with somebody, maybe you don't know a lot about 1 billion or things to compare it with, but maybe you know that 1 billion has 9 zeros. 6 zeros would be 1 million. So maybe you know that a billion has 9 zeros. Maybe you know something along the lines of we're over $1 billion in debt in the U.S. Different things. It's maybe you guess that there's it's 1 billion miles to the moon or to Mars. I don't know the exact numbers on those. But those might be some things that you would discuss with your neighbors. So the second question asks, how many YouTube videos do you think have over 1 billion views? Well, one thing that this book is trying to encourage, or it's not really a book, but this course is trying to encourage, is to not just rely on your class resources when you're doing work. To go ahead and look to and use and be comfortable using things that are found outside the book, resources that are found outside the books. So if we want to know how many videos on YouTube have over 1 billion views, the easiest thing to do would be to go to Google and just Google this. So YouTube videos with billion views. So we have a list here from Wikipedia, and it says that there are currently we go down here, number 79 is the last one that has a 1.00 when we're looking at the column here that says views in billions. And so if we go down, we get to the number 79th video has 1.00 billion views, and then this next video at number 80 is under 1 billion views. So currently there are 79 videos on YouTube with over 1 billion views. It is interesting to note too that the yellow rows that are in this list are ones that are not music videos. So of all of these videos, only 1, 2, 3 videos are not music videos. So there's 3 videos on YouTube that are not music videos that have over 1 billion views. So again, this is one of the things again that our book or our course recommends, is to go to other resources and look things up if you need. Don't hesitate to do that. Don't feel like the materials for the course are the end all be all. So since we actually looked this up, we'll go ahead and write it down. It says, how many do you think? You might have guessed higher, you might have guessed lower. I can tell you over the few years that I've taught this, the number has gone up tremendously as far as how many have 1 billion views. I think when I first taught this course, there was only maybe 6 that had 1 billion views. And so definitely not a number that's going to go down. So now the next question asks, if 1 billion people stood shoulder to shoulder in a line, how long would the line be? Make a prediction. Again, you know, how far do you think that is? Kind of think about that to yourself. Do you think it would be, you don't necessarily have to give it a number like how many miles. You could say something, reference something like, maybe, do you think it would go once around the world? Do you think it would go twice around the world? Do you think it would go from the Earth to the Moon? Do you think it would go across the United States? Do you think it would go from the Earth to Mars, the Earth to Sun? So, you know, we don't know that, but, you know, that's a curious question. So let me just write down here, one of the ones that comes up sometimes is maybe that it would go from the Earth to the Moon. So maybe when we're all said and done here, we'll come back and check one of those types of predictions. So the next question that we have here would be something that we would do in class, and we'll kind of cut to the chase a little bit on this because we're not going to be able to do this, obviously. But it says, stand in line shoulder to shoulder with your classmates. How many people are in the line? To the nearest inch, how long is the line? And what is the average shoulder width of the people in your line? And how do you know? So typically a class would have about 20 students in it. And typically we find that we get an average of about 17 to 18 inches per person. And so we'll kind of cut that in half. Say it's 17 and a half. We had 20 people in class. When we measured that, we might come up with, say, 350 inches for our line. So how many people are in your line? Whoops, I reversed that. So that was actually number 5. So we'll flip these. So say we had 20 people in our line and we got 350 inches. How would we know the average shoulder width of each person in your line? Well, since we have 20 people and it's 350 inches, we would take that 350 inches and split it evenly amongst our 20 people. So 350 divided by 20 would give us an average of, in this case, about 17.5. When we do this in class as a real activity, it doesn't usually come out such a nice number, but we'll go with 17.5. So say that we wanted to know how long the line would be if there were 1,000 people. Well, if each person is 17.5 inches, then if we wanted to know how long the line would be if there was 1,000 people, we would have to take 17.5 times 1,000. Now, you may know already that 17.5 times 1,000, if we wanted to calculate that, because of the 3 zeros, that would actually move our decimal point over 3 spots. But you're never going to have your calculator taken away from you in this class. So let's just go down to the calculator and open it up. And type in what's my calculator down here? Doesn't like my pen. 17.5 times 1,000. Okay? And you see that we get 17,500. So close that up. Actually, we'll just come over here. We don't need to close it up. And we'll write 17,500. So that would be 17,500 inches, which is kind of a weird way to measure something that long, but we'll leave it at that. So then it says, how long would the line be if there were 1,000,000 people? Well, if there were 1,000,000 people, again, we're going to take 17.5 times 1,000,000, which has 6 zeros, and that would give us 17,500,000. And then how long would the line be if there were 1,000,000,000 people? Well, that's 3 more zeros, so without going to the calculator, I could type that in and type in 17.5 times 1,000,000,000, but we can kind of see a pattern developing here. And so that would add 3 more zeros to my answer. So I had 17,500, 17,500,000, 17,500,000,000. And again, these are all in inches, which is kind of a difficult way to measure something that long, but that's what they're asking for right now. So now we're going to move on to Lesson 1C. There is a Lesson 1B that is entitled Building a Learning Community, I believe. And I don't want to just completely ignore that. One of the things that as a learning community for an online class is don't hesitate to email each other through D2L, or probably better yet through MyMathLab. Don't hesitate to go use the resources you have, like the tutoring centers, or try to make some contact with people that are in class and meet on campus. I wouldn't recommend meeting strangers somewhere besides on campus, but I would definitely recommend meet on campus at a tutoring lab or at a library. The Kingwood campus is not completely open, but the SCC is open, and that has the tutoring lab and some spaces. The Atascocita Center was unaffected, and so there's a small library there and lots of study spaces. So if you want to get to know people in your class, I think that that's still a possibility and something you can even do via emails and things. And don't hesitate to try to talk to each other and help each other out, or to go to campus and meet with other students or tutors and things and get some help. There's also an online tutoring service that if you go to our webpage, you'll find a link for, called Brightspace, and it's open 24/7. So that's a good resource if you want to find some help with some specific questions. So now moving on to Lesson 1C. It says to recall that you measured the length of a line of your classmates. Inches are a very small unit of measurement, appropriate for gauging distances smaller than the span of your arms. So larger distances probably would require some larger units of measure. In the United States, we use what's called the customary system, where the major distance are in inches, feet, yards, and miles. Switching from between these distances is called converting units. So it asks us, can you recall any of the unit conversions below? This is something, again, that we would have talked about in class before we actually went into it. So I'll just kind of fill these blanks in to get us this information that we need. Of course, most of us probably know that in 1 foot there are 12 inches, something that we use quite a bit. In a yard, there's 3 feet. Yards to miles is not a conversion that is done very often, so I'm going to hold off on that. But a mile in feet is 5,280. So there's 5,280 feet in 1 mile. So let's pull our calculator up here to do that lesser known conversion of yards to miles. We know that there's 5,280 feet in 1 mile, and we know there's 3 feet in 1 yard. So there should be less yards in a mile than there are feet in a mile because a yard is bigger. So this should be a division. 5,280 feet, divide that by 3 feet in a yard, and we should be able to get how many yards there are in a mile. So 5,280 divided by 3, and we get that there's 1,760 yards in 1 mile. So the next question that's asked is, recall to the nearest inch how long was our line? Well, to the nearest inch, our line was 17.5 inches times 20 people. I don't remember the number off the top of my head, but I'll just recalculate it. And that came out to be, it was 350 inches. And so what type of mathematical operation would you use to convert inches to feet? Would we add, subtract, multiply, divide? So if we wanted to switch this 350 inches into feet, we know there should be less feet to measure the line than there are inches because a foot is bigger. And so we want to divide this by 12 to see how many 12-inch increments there are, because each of those 12 inches makes 1 foot. So I'm going to take 350 inches and I'm going to divide it by 12, and that should get me how many feet are in the line, our imaginary line that we never actually did. So there would be 29. Let me pull this calculator up so you can see this, because it comes out to be kind of unusual. So 350 divided by 12 gives us 29.16 repeating. I know it has a 7 here on the end, but that's just a calculator thing. It actually repeats 6s forever. And so obviously it doesn't make sense to write all these digits out. And so what I'm going to write for an answer, I'm going to change my equals to an approximately. And I'm going to write 29.17 feet. Or I could round it a little differently and I could say 29.2 feet. I think for what we're doing that 29.2 feet is fine. And in fact, if we look to number 7, it says, how long is the line to the nearest tenth of a foot? Well, 1 decimal spot is a tenth. Again, if that's something you didn't know, Google it, look it up. Don't worry about, oh, I didn't know what that means, so I can't do that problem. Just Google it. A tenth is 1 decimal spot. So it's 29.2 feet. And we already have that answer there. And so going on to number 8. It says, think about your answer. Should the number be larger or smaller than when you measured in inches? And we had already discussed that it should be smaller. A foot is a larger unit, so it should take less of them to measure a distance than it does inches. For instance, think about just measuring across a room. You know, you might have a room that's 20 feet wide. Well, if you measured that room in inches, instead of being 20 feet, it would be 240 inches. So it takes more inches to measure a distance than it does feet. So it says, if your answer makes sense, enter the answer in the table below. We'll do that here in just a minute. What is the average shoulder width of the people in your line measured to feet? Okay, so we had 17.5 inches, and we're going to divide that by 12 because there's 12 feet in an inch. And we find that 17.5 divided by 12, I'm doing this on my own calculator, I get 1.45, again, I better pull this up. So 17.5 divided by 12 gives us 1.45833333. So we need to decide how to round that. And so I could do a couple different things. I could say 1.5 because if I rounded it to this spot, the 4 would round up to a 5. or I could round it to this place and say 1.46. That's rounding to the hundredths. Since in the prior question it asked us to round to tenths, I'm going to go ahead and round to tenths. So 1.45 rounds to 1.5 because again I'm rounding to this place. The 5 to the right of the 4 tells us to round the 4 up because it's 5 or above we round up. So I'm going to take this 1.4583333 and I'm going to round it to 1.5. So again, I'm going to change this to approximately since it wasn't exact. And I'm going to say 1.5 feet for the average width of a person's shoulders. So then for number 9, it says, what is the average shoulder? I'm getting ahead of myself. Sorry. Number 8 was this answer. This was actually number 9. So 1.5 feet per person in line. Sorry about that. For number 10, it says, how long would the line be if it contained 1,000 people? Well, if we're measuring in feet, and each person is 1.5 feet times 1,000, that would shift our decimal over 3 spots, and we would get 1,500 feet for 1,000 people. And then for number 11, it asks how long would that line be if it was measured in miles? So if we have 1,500 feet, well, we know from up here that it takes 5,280 feet to make a mile, and those 1,000 people is only 1,500 feet, so it's not going to even be a mile, but we'll see what part of a mile it would be. So 1,500 feet divided by 5,280 feet in a mile comes out to be 1,500 divided by 5,280. We get 0.28409. So I'm going to say approximately 0.28. Again, it doesn't tell us where to round, so it's kind of our choice. So it's 0.28 miles for 1,000 people. Okay, so now by the magic of technology, I've pasted our table in over here for question number 12, and we'll go ahead and fill that in and finish off this lesson here for Unit 1. Later on I'll get Unit 2 posted up, and I'll try to keep up with the units each week so that they're posted up on Monday instead of being a little late like they were today. So anyway, for our table, our group that we imagined that we had was 20 people, and the length of our line in feet was this 29.2 feet. That calculated out one person was approximately, if we rounded, 1.5 feet long, which meant 1,000 people was about 1,500 feet long. Again, we had to round that. It wasn't exactly 1.5, but when you're dealing with large numbers like this, going back and forth, sometimes you have to do some rounding, and that's not a big deal. So the length of the line in miles, after we divided by the 5,280, that was 0.28 miles. So if we had 1,000,000 people, remember that adding the 3 zeros to the number that we're multiplying by just adds 3 zeros to the number that we had, so that would be 1,500,000. So 1,500,000 feet. And then it would do the same thing to our miles. Instead of, we don't have to do any more calculation. We know that if we're going from 1,000 to 1,000,000, that's going to shift this decimal 3 spots. So that would give us, instead of 0.28, we would shift it 1, 2, 3 spots, and that would give us 280 miles. And again, if you're not comfortable with that, you can redo it on your calculator and calculate it out, but that's how it works with adding the zeros on. So see if I can squeeze this in here. If we had 1 billion people, that would add another 3 zeros here. So 1500, 000, 000. So 1,500,000,000 feet, which then would, if we shift the decimal here, add 3 more zeros here, because the decimal's at the end. So if we move it from here over 3 spots, that gets us 280,000 miles for how long a line of 100 billion, how long a line of 1 billion people is. So for one last thing, I just want to go, since our original guess, or one of our original guesses, is would a line of 1 billion people reach to the moon? So let me just Google that and see how long or how far away is the moon. So I'm going to Google distance to the moon in miles, and it's 238,900 miles. And so if we compare that to what we just found, it's actually not far off at all. 280,000 miles is how long we think a line of 1 billion people would be, and the distance to the moon is almost 240,000 miles. And of course, I've done this before, so I knew they were kind of close, so I had a little bit of an advantage there. But just interesting to see that a line of 1 billion people would reach to the moon and possibly back a little bit. So anyway, I hope that these videos will help you with your lessons rather than just doing the reading. And as I said, I'll get Unit 2 up here. If not by the end of the day, I'll get it up tomorrow, which would be Wednesday. And then I'll try to have future videos up prior to the start of the week. I was just trying to learn the technology this week. So have a good start to the semester. Email me if you have any questions, and take care.